Okay, so today we're going to talk about graphing inequalities. So when we're talking about inequalities, we're talking about things that have less than, greater than, less than or equal to, greater than or equal to. All right. And if we're graphing less than or greater than strictly, we used an open circle. When we graph less than or equal to or greater than or equal to, we did a solid circle. We're going to mix it up just a little bit here because now we want to get away from the whole idea of closed circle and open circle. And instead of a open circle, we're going to start using a parenthesis. And instead of a closed circle, we're going to start using the idea of a bracket. Okay. So let's look at a quick example of how this would happen. So if I have x is greater than 3, that means I have a graph and something is happening around 3. And you don't need to go ahead and do all the hashtags for 0 and 1 and 2 and 5 and all the other things. What's happening in this graph is happening around 3. So everything I'm showing you is totally sufficient for my purposes. Right. And at 3, because x is on my left-hand side, I can go ahead, look at the arrow of the inequality and see that I need to do this shading because anything greater than 3 is fair game. That includes all the numbers to the right side of my graph. And no matter how far I go, all those numbers are good. Right. The further and further we go to the right, the bigger and bigger the numbers get, but we don't know where that ends. And so then we end up with the idea of positive infinity. Okay, if you want to do two circles next to each other, totally get it. Okay, so this graph goes on and on forever. I could keep adding one on and I could keep adding, and it's still going to keep on going forever. Right. But at 3, because it's strictly greater than, x cannot be equal to 3, which is where the idea of that open circle came from, that you were going to go ahead and use the open circle to indicate that 3 itself was not included, but anything really close to 3 was totally okay. Now when we're graphing this using the parenthesis and the bracket, I'm still looking at 3. I'm still shading to the right, and I still go to this idea of infinity. All right. But now instead of an open circle, I'm going to use a parenthesis, and the parenthesis is placed such that the arrow that it's facing is like shooting it out like a headlight. Okay, so it comes from the inside of the curve and goes out all the way to infinity. And you're probably like, well, Miss Ann, I don't know why we're doing this because doesn't the open circle work great? It does, but now we got to introduce a whole new idea for telling what the solution is to an inequality. Because remember, the solution can be anything greater than 3. Okay, any x greater than 3 is fair game. Okay, so it could be 4, could be 5, could be 1,000. Okay, could be any of those things. It could also be 3.1, 3.001, decimals. It could be fractions. Okay, so like 13/4, which is greater than 3. So there's a lot of things going on here, and we want to have a simplified way to tell everybody we're including all these different kinds of numbers, but we do not want to write them all down because we don't have that kind of time. Okay, because even between 0 and 1, there are infinitely amount of numbers in this area. And I don't have time to write all those, and neither do you, nor do you want to. Right? So let's talk a little bit about what we're using this for. I want to introduce a couple different ways we express intervals, and I want to talk about set builder notation. And keeping with my idea that x is greater than 3, and that when I graph that, I shaded to the right, I had a set of parentheses right here, it goes to infinity, blah, blah, blah. Okay? Set builder notation looks, we have A braces. And inside those braces, we start with the variable we're working with. In this case, it's x. And a straight line. And then there's this blank space. Okay? And what this says is the set of x such that okay, and then that whatever's in the red line. And what goes in that red line is your actual inequality solved for the variable. So in this box, I would go ahead and put x is greater than 3. So this would read the set of all x such that x is greater than 3. Not much happened here. All we did was take our inequality and put it in this place that was set aside for it. So no problem there. Okay? Then we're going to go ahead and look at something called interval notation. And interval notation is what we're interested in. Interval notation tells us where all the solutions of this lie without having to write all of them. Okay? Interval notation is represented by either parentheses or brackets and the numbers involved with that. Okay, so if I have x is still greater than 3, and I'll do a quick sketch graph again. Okay, and it goes to infinity. Right. I want to read this from left to right. So as I go from the left, I have no numbers, and the first number I run across is my 3. So my 3 will be my leftmost number. As I continue to the right, I continue on forever and ever and ever, and I never ever stop because we don't know what number infinity is. So my number to the right is going to be infinity. Now the parenthesis we used in our graphing, this parenthesis, is going to be at the 3 because we can push really, really close to 3, so that's kind of what the parenthesis does. If I have a parenthesis, I can push and push and push that barrier, but at 3, I'm not going to get there, but I can get really, really, really close. But I can't actually touch 3, but there's a whole bunch of decimals I can have in there. As I approach infinity, the same thing happens. I don't have what number infinity is. I can add 1, add 0.1, add a fraction to it, and make it bigger and bigger. So infinity always gets a set of parentheses, as well as negative infinity. So it kind of looks like something we call an ordered pair, although it is not. And this tells me the solution to the inequality that I was given. Let's go ahead and look at another one. So I'm going to go ahead, I'll say y is less than or equal to -2. All right. The first thing I want to do always is do a quick sketch graph and know what's going on. So at -2, my variable is on the left. So my arrow points the way I should shade, which is to the left. And because it's less than or equal to, it can equal -2. That's where my closed circle or my bracket comes in. And the bracket, you want to think of it as opposed to the parenthesis. Once I hit -2, boom, I'm done. It's like a brick wall. And what tells you that the bracket has to be used is the fact that I have that equality, which is a straight line underneath my inequality. Now, as I go to the left, I can go to the left for forever and ever. I can keep subtracting numbers, subtracting fractions, subtracting decimals for forever and ever, and that number will get smaller and smaller. This is something we call negative infinity. All right. So again, we go ahead and we want to look at set builder. Okay, and set builder notation, remember that set of braces. In this case, I have a y as a variable and a straight line. And I go ahead and put my inequality there. Y is less than or equal to -2. And I'm done, good to go. If I want to do interval notation, okay, then I have to go ahead and look at my graph. And my graph, remember I start from left to right. And I'm going to have two numbers. My leftmost number is -infinity because I don't know where that number actually starts. Okay, so I will have -infinity to the left-hand side. My furthest number to the right is -2 because once I reach there, I'm done. I can't go any further. Now the -2 had a bracket, so that's what I'm going to go ahead and use. Infinity or -infinity always gets a set of parentheses because we never quite know where that's ending. And it's going to end up right there. Okay, so we graph it really quick. Go ahead and do set builder, do interval notation. We'll have some more we'll add on to this, but I want to do one more problem just for graphing purposes and not for interval notation. Even though you can do it, it's not what we're going to talk about. It's not important to you at this time. So I want to look at 3 is less than x, which is less than or equal to 12. Okay. Now in this case, x is between two numbers. All right. So when we do our graph, we're looking at what's interesting between those two numbers, 3 and 12. Notice I don't care about what's going on in the middle. All right. Now x is in the middle between those two, which means it's not going to go past 3 or past 12. So I'm going to shade in the middle. X has to be in here somewhere. All right. On the left-hand side, I have a strictly, this is greater than, so x has to be greater than 3, because remember x is on the wrong side per se. If we do x on the left and flip it, x has to be greater than 3, but x also has to be less than or equal to 12. Okay, so at 3, because it's strictly greater than, we need a set of parentheses. Because it's less than or equal to -12, that gets a bracket. And so in here, our interval notation, I only am between 3 and 12. 3 has a parenthesis, 12 has a bracket, and that's my interval notation. Okay. Well, I'm not going to worry about set builder notation with this, but it'll be very similar. But interval notation is just between the two numbers that you had. So go ahead, work on the practice problems, and I will go ahead and see you in the next lesson.